sine law doesn't work, what do you do? Well, what you do is use the cosine law. So today I want to make sure we know when and how to use the cosine law to solve acute triangle problems. So have a quick look at these two little triangles, right, and show why you cannot use the sine law. So remember, in order to have the sine law, you need a pair of matching sides. And in this case, right here, we do not have a pair of matching sides. We have all the angles. Well, we have one angle, but we can't figure out either one of these, and that's what we need. So again, quite simply, we do not have a matching pair. And that's what we need for the sine law. Matching pair of sides and angles. As well, with this one over here, we don't have a matching angle and side as well. We have all three sides. So again, exact same reason, do not have a matching angle and side. And that's what we need for the sine law. So in order to solve the two triangles above, we could go ahead and do exactly as we did with the sine law and make two right triangles and try to figure out some more complicated algebra, but we're not going to do that. What we are going to do is we're going to use the cosine law. And here are the three versions of the cosine laws that we could use, but they're all the same. You'll notice a pattern. They all have a squared, b squared, c squared, and then they all have minus 2 something something cos of something. So again, what you should see is in each one, you should see the Pythagorean part. So here is the Pythagorean theorem part. And again, Pythagorean theorem only works when you have a right triangle. So what we also see is we have this extra stuff. So it's adding on to the Pythagorean theorem, and this is for the non-right triangle stuff. So again, if we have an angle that is less than 90 degrees or greater than 90 degrees, it's this extra part of the formula that actually counteracts that and allows us to solve an equation. So again, I want you to notice the pattern, and there are a few patterns in there. So I'm just going to look at this one right here. When you have little c as what you want to solve, at the very end you have cos c, and then in between you have your a's and b's and a's and b's, and it's similar above. So the one above, you see b squared, you see a big B, and then you see a's and c's on the inside. So this formula is actually really easy to use. There's only two kinds of questions you need to be able to answer. Find a side and find an angle. And the angle is a little bit trickier algebraically, as long as we don't make the common logical mistake, then this is quite easy to solve. And I'll try to point out the algebra in example number 2. So here's example number 1, solve for q, little q. So again, if you are uncomfortable with the letters that I've used in these examples, just change them to A, B, and C, anything you want. But I'm going to actually use the little formula, and the little formula with the letters would be whatever little letter squared is equal to the other two letters, r squared plus s squared minus 2 times r times s, the cosine of whatever letter we started with. So again, there's a nice little pattern there. It's easy to remember if you had to. You don't have to memorize it, by the way. And then going ahead and plugging the formulas in, the letters, numbers into the formulas, I'm just going to go ahead and do that. And the great thing now is I can simply plug this whole nasty mess that you see on the right-hand side into a calculator. So I'm going to go ahead and do that one. And what we end up is 3.1 squared, 3.1 squared plus 3.2 squared minus 2 times 3.1 times 3.2 times the cosine of 66. And when we do that, we get 11.78. So that's equal to 11.78. Now remember, that's not what q equals. That's what q squared is equal. So in order to find out q, we simply take the square root of 11.78. And again, I should still have that on my calculator. So I'm going to do that to the square root. And I get 3.4. And in looking at this, remember, we always want to ask ourselves, does that make sense? And right now, we're going to have to trust it. So again, we use this new formula. And as long as we plug the right things in the right spot and simply use our calculator, everything works out quite straightforward. Now, to find the angle is a bit trickier. Because remember, we ultimately have to isolate. I guess we should make note of that. Okay, we have to be careful with the algebra when you're finding an angle, because what we have to do is isolate. Well, really what we want to isolate, we don't want to isolate the letter F. We need our calculator to isolate the big F. We need to isolate cos F. So what I'm going to do is I'm going to use my formula. And if I use the letters, it would be, I want to figure out big F. So I'm going to have to use the little f squared. Little f squared is equal to d squared plus e squared minus 2 times de cos big F. And I'm simply going to plug in everything I know. So little f is 3.6 squared. Little d is 2.5 squared. Little e is 2.6 squared minus 2 times 2.5, 2.6 cos F. So again, here's our algebraic challenge. We got to get rid of this. Now, again, what I would highly recommend you do is you figure out what each one of these numbers is separately. Don't plug them in all into your calculator, because you can't do that. So what I'm going to do is I'm going to expand them all out. Again, I have to use my calculator here. And here's what we end up with. Now, we're going to go ahead and isolate cos F. So here's a little equation. Now, again, I want you to recognize that these two things are just simply numbers. They're like terms. And what we could do is we could add those two numbers together and subtract them from both sides. So when I add together 6.76 and 6.25, we get 13.01. So we get 12.96 is equal to 13.01 minus 13 cos F. Now, these two things right here are not like terms. Again, here's that algebra. You cannot combine. When you do a few of these examples, you'll get in the habit of not doing this. So really what we have to do is we have to subtract 13.01 from both sides. And that's what we'll do first. Subtract 13.1 from both sides, and we end up with negative 0.25 is equal to negative 13 cos F. And then in order to get rid of the negative 13, we're going to divide each side by negative 13. And what we get is the cosine of F is equal to 0.0192. So what we've done is we've done all of that algebra, and we have isolated cosine F, but now we use that button on our calculator, our second cos button. Again, that's the button we always press, we will forever press in order to find an angle. And our calculator gives us cosine -1, and we plug in the ratio. And what we end up with is, well, here, let me do that. So second cos of 0.0192 equals 89 degrees. So here's our 89 degrees. So again, with practice, this calculation becomes pretty straightforward. So again, I guess the big question here is, how do I know when to use the cosine law? Well, I could say to you when you don't have a pair of matching sides, but that would be when not use the sine law. Here's when you use the cosine law. When you have two sides and the included angle. An included angle is the angle between the two sides. So there's one example, and that's like one of the examples above. And the other time, just like one of the examples above, is when you have all three sides. So you have no angles at all. And if you have no angles, you have no matching pair.